In this video, we're going to go over how to derive the quadratic formula. There's two main things I want you guys to get out of this. Number one is how to actually derive the quadratic formula, but perhaps even more importantly is the technique behind deriving it, which is called completing the square. That's really the only challenging or creative step behind getting this equation from here. All right, so what is this? To recap, if we're presented with this equation and we want to find which values of x make this 0, this is your general solution. Now, let's examine a few cases. If we just had ax squared equals 0, that would be pretty easy. We could say divide both sides by a, so x squared is also 0. X is the plus or minus square root of 0, which is just 0. All right, so that's not very interesting. What if we had just these two terms? So then we could say x times, we're going to factor out the x times ax plus b equals 0. So that means either x is 0 or this thing is 0, which would mean that x equals negative b over a. So again, if we only have some of the letters, it seems like we're able to solve it pretty easily. Let's say we have just these two letters. So we have ax squared plus c equals 0. So we could have x squared is, move the c over, divide by a, and x would be plus or minus square root of negative c over a. All right, again, we found our solution for x. What if we have just bx plus c? That's not even a quadratic equation. That's back to basic algebra. So here x is negative c over b. So these are all pretty easy. The challenge comes when we have all three of these. And again, I like to think of this as kind of like Siamese twins. We're trying to isolate the x, but we have different powers of x. So I'm not even sure how we would try to do this. So we could try to factor this out. X times ax plus b equals negative c. But then this is not 0. So you don't have a nice case where, like, it's not just x equals negative c and this is 1, or this is 1 and that's negative c. This could be like negative c over 2, and that could be 2. So there's so many possibilities. So this approach doesn't really work because we also don't know what c is. That's not giving us x in terms of an actual, sorry, we do, correction, we do know what c is, but this is not a really great approach. Okay, so what we want to do is be able to get from here to x equals. We want to isolate the x. And again, because we have these two x terms, they're not the same power. If this were also just an x, then we could say this is x times a plus b equals negative c, and x is negative c over a plus b, and we're done. But these are different powers. Okay, so we need a more heavy-duty approach, some tricky idea here. Now, the reason we did expanding and factoring before, one of the reasons is going to help us solve this. So let's go back to something like this. And we could see that we could factor this. So, and this is going to be the inspiration behind this. So notice we have, again, sort of the same problem. We have x squared and an x term, just like here. But by factoring this, we're able to create just a single x, which we can then take the square root of both sides, subtract 5, and solve for x. So we need to turn this problem into this problem. Before we even try to do that, let's imagine this is not a perfect square. So let's say this is a 26. So then we could sort of squint our eyes and pretend it's a 25 and say, whoops, my bad, it's not really a 25, it's a 26. So if I expand this out, I'm going to get a 25, so I have to add an extra 1 to actually get the 26. So this is still pretty good for us. If we can solve this for x fairly easily. Subtract 1, take the square root of both sides, and subtract 5 from that. Again, this is imaginary, but this is just an example. Don't pay attention to the actual values. All right, so that's the idea. We can, whatever this is, we can make it into a perfect square with some little compensation. All right, so that's our plan of attack for this problem. However, notice there's this pesky little a, and it would be much easier if that weren't here. So our first step is divide everything by a. And by the way, as we're doing this, notice how it's going to gradually start to look like this. All right, so we've divided everything by a. That's gone. That's b over a, c over a. 0 over a is just 0. All right. Next, we're looking for something with an x squared that almost gets us this. Now, if you remember from the previous example, the way to get this 5 is just to have that 10. So what we're going to do here is just have whatever this is. So since that's b over 1a, we're going to do b over 2a. However, when we expand this back out, this is b squared over 4a squared. But that's not what this term says. So we need to do two things. A, add that back in because we still don't have that. And subtract out the new garbage. That's going to be this, which this is going to generate. All right. So again, we're trying to make this look like a perfect square. But because of the c over a, this is not exactly equal. So these two terms wiggle that constant term to make the c over a term come out exactly as it is, which is right here. And this subtracts the expanded version of this term squared. All right, so all we're going to do now is basically solve for x. We've done all the hard stuff. Now it's just basic algebra steps. Notice the x is by itself, but there's just a lot of other stuff going on. So let's move that over. So I'm going to move both of them over at the same time and reverse the order. So this is going to come first. Next, we're going to undo that squared. So we're going to take the square root of both sides, but not just the square root, plus or minus, because remember the square root can be, for example, x squared equals 4. The answer can be plus or minus 2. So that's gone. And now all we have to do is subtract this. So instead of putting it at the end as a minus, I'm going to put it up front with a negative. All right, so hopefully you're seeing this is looking very similar to that. And in fact, we're almost done. The negative b over 2a, we already have that. We already have the b squared. It's just some, like this doesn't look really great. So all we have to do is give these a common denominator. That's a 4a squared and that's an a. So we have to step the a up to get it to be a 4a squared. So we have to multiply this by 4a. So 4a here, 4a here. So that I'm not going to rewrite the whole thing. That's going to turn that into 4ac over 4a squared. And now since these are the same, we just have one denominator. Now luckily for us, the square root of 4a squared is just 2a, which just happens to be that same 2a. So now we can get rid of this and extend this division to the whole thing. So notice this is now exactly that. And we're done.